Hello, welcome back to Math with Patrick. It's April 2nd, and we have problem 92 from the Daily Epsilon calendar to solve. And of course, the answer is 2. Find the area of the right triangle with hypotenuse 3 and whose legs differ in length by 1. So anytime I'm working with a geometry problem, my first instinct is just to draw a picture. And we have a right triangle. That just means we have a triangle, three-sided shape. The right part of it means that we have a 90-degree angle in one of the corners. And the hypotenuse is the longest side, or the side opposite from the 90-degree angle. So the hypotenuse is going to be 3. And the legs differ in length by 1. So it could be like, I could tell you what it's not. It's definitely not 1 and 2. Because if you try to line up a stick with length 1 and a stick with length 2, it's going to line up perfectly with a stick of length 3. And that's not a triangle. And then if I try doing the next numbers, 2 and then 3, this is already too long because, you could even kind of see the hypotenuse should be longer than this side, and it's not. So it looks like the sides here aren't going to be whole numbers. And if they differ by 1, how about I'll just call the short one x, and then the longer one x plus 1. To find the lengths, we could use the Pythagorean theorem. And then to find the area of a triangle, you essentially just do half of the area of the rectangle that it's enclosed in. And to find the area of the rectangle, I'm just going to do like this base times its height. So I want to find these lengths, and I don't have a better way to do it besides trying the Pythagorean theorem. A squared plus b squared equals c squared. This is true for any right triangle. And specifically, the c is the hypotenuse, and then the a and the b are what you can fill in for the lengths of the legs, or the non-hypotenuse sides. So, and it doesn't really matter which one's a or which one's b. So I'll just say a is going to be the side with the x, and then b is going to be the x plus 1, and then this is going to be equal to 3 squared, or 9. And fortunately, I have one equation and one unknown, just the x, and so I know that I could solve for this. Maybe if I expand everything, maybe it'll make it a bit more clear. Multiplying binomials, so I'll just kind of write out what that squared means. I'm just multiplying something by itself. When you're multiplying binomials, just make sure that you're doing all the distribution you need to do. It's not x squared plus 1 squared. You're missing some of the extra terms in there. It'll be x squared plus 2x plus 1. And this is still going to be equal to 9. And I guess I could combine my like terms. So I have 2x squared plus 2x plus 1 equals 9. And then that would mean that the 2x squared plus 2x is equal to 8, because 8 plus 1 is equal to 9. All of my terms now in this equation are even, so I could divide both sides by 2. I'll get x squared plus x is equal to 4. And earlier I tried to get whole number values for that x, and it didn't really work out. So I feel like my best bet here is to either use a quadratic formula on this or to do the completing the square strategy. And for me personally, that completing the square strategy is best when this value right here is even. And since it's odd, I don't really like trying to do that completing the square process. So of my various quadratic tools, I'm just going to opt for the quadratic formula. So let me put it in standard form first. X squared plus x minus 4 equals 0. Then a would be 1. That's that leading coefficient. B is 1. That's the coefficient in front of your linear term. And c is going to be negative 4. That's the constant. And then plugging it into the quadratic formula, we get x equals negative b plus or minus the square root of b squared minus 4ac. Oops, a is just 1. And then all over 2a. I'm going to simplify the discriminant. That's this part underneath the square root. I see a 1 plus a 16. So that's going to be root 17. And then, a is just 1. I did that again. So I can do 2 times 1. That's just a 2. So I have two potential values for x. I have a positive value, 1 plus root 17 over 2. And then I have this negative value, 1 minus root 17 over 2. I know that's negative because like root 16 is 4. And so this is going to be a little bit bigger than 4. And then 1 minus something a bit bigger than 4 is definitely negative. Working with geometry and triangles, it wouldn't make sense for a distance to be negative in most cases. Like, sure, maybe you could say that a distance left of the origin is negative, but I'm just going to throw out that negative solution here just because I don't think it's going to make sense in the context of my geometry diagram. So x is equal to 1 plus root 17 over 2. So I guess I could redraw my triangle and put 1 plus root 17 over 2. The hypotenuse is still 3. And then this side right here is just 1 more. So I think that's going to be 3 plus root 17 over 2. You could imagine like adding on a 2 over 2 because the denominators need to match when you're adding fractions. And then this 1 and that 2 can combine to create the 3 that I made. So now that I have the lengths of the legs, I guess I could find the area of the triangle, right? So area is going to be half times that base, which is 3 plus root 17 over 2, and then times the height, which is 1 plus root 17 over 2. And how about let's collect up all those 1/2. So this 2 and that 2 and that 2 can all become a 1/8 together. And then I'll just rewrite the numerators that I have. Here's another binomial times a binomial. And so I'll do the multiplication here quickly. It's the 3 times the 1 plus the 3 times the root 17 plus the 1 times root 17. So overall it's this. And then finally we have the plus 17 at the end. And I'm a little bit confused because this is supposed to be the number, 2? And this is an irrational number. So we're going to pause for a second and figure out where I went wrong. Found it. Also, if you notice, I just did a little costume change. It's actually tomorrow. Well, it's today, and I filmed the first part yesterday, whatever. Like you saw earlier in the video 2.5 minutes ago, I missed this negative sign, so I missed that negative sign. So I missed that negative sign. So this isn't a 3, but it's a 1. I think I'm all caught up. Hopefully. Okay, and let's change these. I guess I could keep this to be a positive 1 and make this the negative 1. That's a negative 1. And then let's redo this binomial multiplication. The negative 1 times the 1 makes a negative 1. And then fortunately, the middle terms cancel out here because the negative root 17 plus the positive root 17 makes a 0. And then so we still have a plus 17 at the end. And there we go. 1/8 times 16 is just 2. So there's the area of the triangle. I also noticed that I could have made a little shortcut here because not only does this process work with, doing the quadratic formula and whatnot, but I could have branched off from my work right here. And let me show you why. So again, the area formula for a triangle is half base times height. And using the variables in the diagram, area is going to be half times x plus 1. That's just, both dimensions, the vertical dimension first and then the horizontal dimension second. X times x plus 1 is the same thing as x squared plus x. Here I'm distributing this x into this binomial. And maybe you're seeing what I'm talking about now, where x squared plus x is 4. So I can just do like one of those Indiana Jones substitution things. You fill up a bag of sand to match the same weight as an idle on a pressure pad, and if you swap them out real quick, I guess with the math, the timing doesn't matter, but if you swap them out and they're equal, well, you're allowed to do that and nothing bad will happen. So this 1/2 stays, and this x squared plus x turns into that 4 from the equation up above. And either way you do it, maybe you actually find the lengths of this triangle, or you solve it cleverly and you don't actually figure out the lengths of the triangle. Either way, the area is 2. So thank you for coming along. I'm happy that I was able to offer 2 separate ways to get to the same answer. And I'll see you in tomorrow's video. All right, bye.